So we've moved from indefinite to definite integrals. So that means we're going to see some numbers on our integral symbol. Okay, we're going to use the fundamental theorem to plug them in. If you have no idea what I'm talking about, make sure you go back and watch the first part of the videos. Okay. All right, so in this one here, and you'll notice I repeated the picture a whole bunch so that you could draw on it and understand where the shading is on it. So they want us to go from x equals 0 to x equals 3. On your integral symbol, the numbers are always going to be intended to be x's, okay? So what I'm going to do is I'm going to look for some shapes in here, okay? We are going to, so I'm looking at shapes. So I see a quarter circle, okay? I see a rectangle, and I see a triangle. All right, so I'm basically going to find the areas of those and add them up. Okay, not that hard. So integral from 0 to 3 of f of x equals. So I'm going to do the quarter circle first. So can you guys tell me what's the area of a circle in the chat? Quick. What's the area of a circle? Who remembers? Area of a circle. Uh-oh, we don't remember area of a circle. This is not good. I'm going to keep that one blank while we're looking at the others. Rectangle will be 2 times 1. And then the triangle is 1/2, the base of 1, the height of 1. Did anybody remember the area of a circle? Nobody? Pi r squared. There we go. Okay, there we go. Maybe there were a few. Thank you, Javon and Casey. Pi r squared. So the radius length on this is 1, 2. We're going to square it, and then we divide by 4 because I only want a quarter circle. Okay. We are going to leave our answer in terms of pi, but we are going to simplify a little bit. The 4s, because that's 2 squared is 4, is going to cancel. Plus 2, and then this is just going to be plus 1/2. If I turn that 4 or 2 into halves, it'd be 4 halves. I know that's really super sloppy, so I would have pi plus 3 halves as my answer. Done. Okay, so literally find the shapes you have. And remember, it's the area between the curve and the x-axis. Okay, that's what you're looking for. So we're looking for a geometric area in these problems. All right, we're going to move on, and we're going to look at the fact that we've got to now go from 0 to 4. Okay, and I'm going to look at my shapes. So it looks like I have the quarter circle again, right? I've got the rectangle again, and I've got 2 triangles. All right, well, I already know this top part here. I already know the area of that, right? So I'm actually going to just kind of copy from my previous, because I know it's a Wednesday pressed for time day. So it's pi plus 2. So that one, this area was pi. This area was 2. This area was 1/2. And I'm writing it out like that on purpose. Now let's talk about this area down here, okay? When your area is underneath the x-axis, underneath, I didn't even spell that right, did I? I have no clue. That means that we're going to have negative area because it's underneath the x-axis. So whatever my area is, I know it's going to be negative. I'm still going to have base times height, so it's going to be 1 times 1 over 2. Which means that this 1/2 and this 1/2 cancel, and I just get that my area underneath that curve is pi plus 2. Okay. We could have used the fact that they look like they're the same shape and one's positive and one negative. We just know that we're going to cancel them. All right. I am going to look at C now. So C says that we have to go all the way from -3 to +3. Okay. I want to know from you guys, what's at least one shape you're seeing in there? So tell me in the chat. Give me at least one shape. I can go back up to part A. Sorry. What is at least one shape you're seeing in there? In that 0 to 3. Okay, Brianna says a half circle and a trapezoid. Oh, I like the trapezoid. We'd have to do less math, right? A rectangle, trapezoid. All right, let's go with the trapezoid because that sounds interesting. Nobody wanted to do the triangles, huh? All right, Brianna, did you get what you needed on A? Is that a 3/2? Yes. Okay, we're gonna keep going. All right, so I'm gonna go with the trapezoid because we could break that into any shapes we wanted, right? I like the trapezoid and the half circle. Now it looks like an alien spaceship, right? Everybody got like the little like thing that, I don't know. It looks like an alien spaceship in my brain now. All right. So as long as we know those area formulas, we can use whatever shapes we want. So I like the trapezoid. Okay, so half circle. So pi, the radius length is still 2. We're going to square it, but we're only going to divide by 2 because it's only half a circle. Okay, plus my trapezoid. I know trapezoids divide by 2. And then I have to do the base 1. So, ooh, that's not what I meant to do. I hit erase. All right, so base 1, let me count it up, is 1, 2, 3, 4. Base 2, 1, 2, 3, 4, 5, 6. And then my height is just 1. That's not so bad. Okay. All right, let's see what we got here. So let's see, I'm seeing 2 into that. There's 2 2's on top, so I would just get 2 pi out of that. 4 plus 6 is 10, divided by 2 would be 5. So 2 pi plus 5, probably we'd be more likely to see 5 plus 2 pi. They like to put the pi at the back. Okay. All right. Hopefully I can do the next one. I didn't study ahead of time on this one. If f of 0 equals 5, what is the value of f of 3, where f is the antiderivative of f of x? Okay. So what they are telling us here, okay, so a little bit different of a problem. And you probably won't run into this in the homework, but this is very AP-esque, okay? Is that we are going to be given an initial condition. And AP loves to do this. It's telling us we're starting at that x value. When we start at that x value, we're starting at 5 already. So we already know we're at 5. And then we're going to add that to the integral from 0 to wherever they want us to stop of f of x dx. And I know that was kind of tricky. Okay. Luckily, we already know what the answer is from 0 to 3, don't we? Didn't we find that in part A? So we've got 5 plus whatever we got in part A, which was pi plus 3/2. So I could turn that into 10/2 plus pi plus 3/2. So that's the same thing as saying 13/2 plus pi. And I'm sorry if I'm going too fast. So again, let me repeat what I did on that one. So now that you see it all in one spot. I noticed they gave me an initial condition. That means wherever I'm starting my integration, I have to start with that y value. I know I'm already at 5, and then I'm going to add some stuff to it. Okay. The x value I start integrating at is 0. I go from 0 to whatever they told me to stop at, which was there, 3. Okay. And then, so this part here I get from the graph. So I'm going to go 0 to 3. We already had the 0 to 3 information from an earlier example, so I didn't rehash all of it. Okay. All right, let's look at E. Okay, so again, I have an initial condition. The y value I am starting with is -2. So it's going to be -2 plus something. Can you guys tell me the x value that I'm supposed to start with? So it's going to go at the bottom of my integral. What is that saying in the initial condition? Tell me the number in the chat. What do you guys think? All right, good job. -2. Okay, we're going to end at this value here too, of f of x dx. Now we haven't calculated that one yet, right? -2 to 2. So I'm going to actually have to do the calculation. It looks like I get a half circle and a rectangle, right? So -2 plus my half circle. So pi, the radius is still 2 squared, but only divided by 2, plus the rectangle, 1, 2, 3, 4 times 1. All right, we know 4 times 1 is just 4, plus that negative 2 would be 2. And then one of those is going to cancel, so plus 2 pi. Not too bad. Okay, but do you see how they gave us a graph? And with that graph, we could have also determined increasing, decreasing, and concavity. Okay, likely that will be the derivative graph, but then they'll say, hey, we want you to integrate it and find the area underneath it. Plus, we want you to find where it's increasing, decreasing, concave up, concave down, or increasing and concave down. Okay, so you're gonna use that one graph and ask like 4 questions off of it that are not related to one another. Okay, that's the way the AP test is. Okay, but I can't get, it's hard to give you a full free response because you have to be able to do derivatives and integrals. You're getting there, we're almost there. Okay, so this is a delta math problem. I pulled it right out of delta math. This is what this is gonna look like. If my other class pops in, you know that we're just, we'll at least get through this 10. I don't know what was going on with my numbering either. This is example 10 again, apparently. So apparently I couldn't count when I was putting these notes together. All right, it says the function f is shown below is comprised of a semicircle and piecewise linear segments, and sometimes that's more the phrasing you'll see on the AP test. What is the value from -8 to 9? Okay, write your answer in simplest form. All right, so what kind of shapes are you seeing? Tell me in the chat, what shapes are you seeing there? All right, triangles, cool. Half circle and triangles, good. Half circle, triangles. Okay, we got 2 triangles. All right, so I'm going to just start. You write the notation as -8 to 9 of f of x dx, and then an equal sign, and then we're going to write out a little area formula. So I'm going to start with this triangle. 1, 2, 3, 4, 5, 6, 7, 8. I probably could have just read that, right? So base of 8, height of 1, 2, 3, 4. Triangle starts with a t, we divide by 2. Okay. The next piece is the circle. All right, we know it's a half circle, so I'm going to divide it by 2. Pi times the radius squared. Okay, radius is going to come out of the middle. It looks like I've got 1, 2, 3 for the radius. All right, and then down here, what's going to be special? Let's see if we've learned anything. What's going to be, good morning, Casey. We're almost ready for you. I'm going to finish up this example with them, so hang on, okay? All right, what is going to go, what's going to happen with that triangle? What's special about that area? You guys are already putting negative in there. I was totally half through the question and then welcome Casey to class, didn't I? All right. It is negative area. So I want to start with a negative. You guys pick up on this fast. You're awesome. 1, 2, 3. So base of 3. Because I took care of the negative in here, I don't need to worry about the height being negative. Okay. So 1, 2, 3, 4, 5, 6. And then divide by 2. All right, let's see. I'm going to cancel a little bit. 2 goes into 8 4 times. 4 times 4 is 16. Ooh, I can't cancel anything there, right? 9 pi over 2. 2 goes into 6 3 times, so minus 9. So let's say 16 minus 9 is that 7 plus 9 pi over 2. Okay, we should be able to handle this. All right, I'm going to we're going to really quickly squeeze in 11 before we're waiting on BC to get here. All right, this one is a little crazier, okay, and I'm actually glad we're going to do it really quick. And it's okay because BC needs to know how to do these too, so Casey's getting her quick refresher right now. All right, it says we've got to go from -8, okay, all the way to +4. So I'm stopping here. Notice they gave me extra, right? So I don't need this chunk over here. I don't need this chunk here. Okay, that part's out. What do you notice about, let me trace them in this green, this triangle here and this triangle here? What do you notice about those two? What are you thinking? Good morning, Anna. We're finishing up our AB lesson.
Okay.
Just hang on. One's going to be negative, one's going to be positive. So aren't they going to cancel each other out? So these two, this is going to be positive, it's going to be negative. They're going to be the same area. They're going to cancel each other out. So I'm just going to ignore them for now. Okay. What I want you to be aware of is this piece right here. Okay. Look at that piece right there. In what I really want is, let me find a totally different color, purple. is that area in there. So I've got a rectangle that I'm going to take a semicircle bite out of is what I'm really trying to find here. Okay, so this one's going to set up a little bit differently. So we're going to go from -8 to 4 of f of x dx. You guys have already told me, hey, we had a triangle, we had another triangle, they're going to cancel each other out. So I don't really even care about that part. Okay, I'm kind of skipping steps because I know that I got to get my other class done here. All right, so I'm going to talk about this rectangle. 1, 2, 3, 4, 5, 6, 7, 8. So 8 times, let's see, 1, 2, 3, 4, 5, 6, 7. All right, and we know that it's got to be negative because it's underneath. So I know that that's 56. And then we're going to subtract the semicircle. But I also know that that area is negative. So I'm going to go negative. And then it's got a radius of 4. So pi times 4 squared divided by 2. So that's going to go positive. Let's see, 2 goes into, oh, I'm not going to do that. Let's not cancel yet. So it would be 16 pi over 2, which would be -56 plus 8 pi. Okay? All right, so AB, what you have left to do. Good morning, Madison. I just noticed you. Okay, we're finishing up AB. We'll be done in like just a second. We'll all listen to the joke together. So ABC, you get to start with your joke today. So what you have left to do AB. If you haven't finished the first half of this lesson, you now need to go do it. Okay. Then you need to make sure you're working on the assignment. It's a Delta Math. Okay. So let me do the joke of the day. If there's any questions or concerns go while I'm getting the joke of the day out, go ahead and put them in the chat. And we will answer them really quickly before I start with BC. Is it coming? No, it's not. Let's try that again. It's got a good one today. There it goes. Okay. He's apparently got a game controller on his head.
Hello. Why isn't Pi on Twitter? Because even 280 characters isn't enough to express itself. I'll be here all week because I live here.
All right, you guys. All right, AD, you guys have a great day. I will see you tomorrow. Come ready to do some more integration. Okay? Bye, Brianna. Bye, Bianca. Bye, Stephanie. Bye, Cynthia.